Okay, hope we can start now. Good afternoon, everyone, and welcome to the webinar. This is Mahesh with you from Graphic International. Most of our customers know Graphic as an MFP supplier, a printer supplier, and a print management solution supplier, and a distributor of Ricoh. And Ricoh, of course, is famous as a manufacturer of Ricoh printers. Then today's topic is something totally different. You'll be wondering that how MFPs and cybersecurity. So basically, Ricoh is, for the last few years, Ricoh is collaborating with many top brands in the market to bring more number of solutions and product to our end customers. This Bullwall pioneers in the cybersecurity is one among them. I have Mr. Toby to give you more insight and information on this new product. Along with Toby, I have Vicky Leaf, Marketing Manager, Ricoh International, and Majid Al-Quaisi, the Solutions Manager, Ricoh Middle East. So yeah, without taking much time, I'll hand over to Toby. Welcome, Toby.
Hi there, thank you very much for having me on the call. I just want to start by doing a quick agenda for the session. So what we're going to do is we are going to go through a little bit of the problem that we're seeing around ransomware, and we'll give you a few statistics from global ransomware sort of variants and stuff like that, just to give you a highlight of what we're seeing globally around ransomware. We're going to talk a little bit about prevention versus outbreak containment. Now, what we're talking about here is how we secure our environment today. So we do a lot of prevention. We don't do any outbreak containment, and it's something that we need to address. I'll talk about the solution. I'll talk a little bit about the architecture of the solution. We'll talk through a workflow of a ransomware attack, and then we'll show you a ransomware attack and a few configuration stages for the solution. And then we'll talk a little bit about the free assessments that we offer as well. So that's the agenda for today. And I will continue with the slides. So yeah, so the first thing we want to do is talk a little bit about the actual issue that we're seeing. Now, this is something that is increasing year on year. It's becoming a very big problem for lots of organizations, large and small. It doesn't matter how big the organization is. If you have data, the cyber criminals will be able to use that data if they are able to access it and encrypt it. And the size of this is the scale of this problem is monstrous. So there was a statistic released just recently that globally, just one threat actor announced that they made over $1 billion in revenue, and these are cyber criminal guys. So you can kind of see the reasoning behind it. It's very lucrative for them, and we're seeing that every 14 seconds we are seeing a ransomware attack globally. Somewhere somebody is being hit. Now all that is really scary, but my thing is that the scariest thing is to this is what we're struggling to be able to detect when it comes into our environment. Now, 64% of the breaches that have been reported weren't actually picked up by the technology we're putting in place. It's actually picked up by our staff. I want to drill into this. What we do today is we're very much a prevention approach to security. We have silos of different types of different parts of the business or different parts of the infrastructure that we try to secure. We'll have network security, endpoint security, application security, and a whole bunch of other stuff that we do today to try and prevent the bad stuff from happening, try and prevent these outbreaks from happening. And one of the things you see here with all of these tools is they are all prevention tools. And I'll come on to that in a bit more detail on the slide in a moment. But the problem is that we're investing a lot of money into prevention. However, it's not working nowhere near enough and protecting our corporate information and our corporate identity, and also that critical IT infrastructure. This is why this statistic really worries me, in the fact that we are just not well protected when it comes to ransomware. One of the other things is, as we know, ransomware is here to encrypt our data at a very fast pace. What does that actually mean, though, to an organization once we've been hit? Is that it's not just our live data that it goes after. It goes after our corporate data. It goes after backups. It goes after application databases. It goes after virtual machines. It goes after everything, right? So once we start to see that encryption happening and the speeds that it's happening, it's not long before the environment is ground to a halt. Now, that has an impact on a lot of things. So firstly, from an internal perspective, it has impact on our users and able to access any system, any application, or any data. So our users are unable to work. But let's think of it from a public perspective. If I'm a bank and I have banking applications and my application database has been encrypted, and we've seen this so many times, is the banking apps are down, so people can't transfer money, make payments, all of that kind of stuff. So it has a bigger impact than just a few files being encrypted. And this is why you see these very high figures when it comes to things like how much is it going to cost an organization. Not only that, this also again was quite scary in the fact that we're seeing far too many of these organizations that get hit actually pay the demands. And let's drill into that a little bit and understand why this is. And after doing some research on this, I found that the reason why we're paying the ransom is because we do not have the belief and the faith in our ability to recover from a ransomware attack. We do not have the ability to recover our data once it's been encrypted. We can't decrypt it ourselves because the decrypt methods now are so complex. So we have really no other option, especially if the ransomware attack has also then penetrated further into the environment and gone into our backups. If our live data and our backup data is encrypted, we have nowhere else to go other than to pay for the decrypt keys. Now, unfortunately, these decrypt keys don't always work, and it doesn't unlock all the data. Sometimes it unlocks none of the data, sometimes it unlocks some of the data. That's not very good when this data is business critical. So putting our faith in the fact that these cyber criminals are going to give us all of our information back is probably not the best thing to do. And we're paying them a lot of money to get this information back. But let's think about it this way. As a cyber criminal, I've gained access. I've deployed ransomware into your environment, encrypted as much as I possibly can, if not all of the data inside. And now you're paying me. I'm going to keep hitting you time and time again, and we see this far too often where people are getting re-hit and re-hit and re-hit and paying out even more money than they should be doing. So we need to start thinking a little bit differently. We need to start thinking, what is my approach? Either do I keep paying this money and possibly run out of money, or do we do something differently? And this is where we start to look at this containment. Yeah, so the idea of not now trying to block it from coming in, trying to say, right, okay, I need this last line of protection around my environment. I need to be able to protect my environment if all else fails. So I want to drill into the picture of this and how we are different. And as I said before, we do prevention. This is prevention at its best. So we build a perimeter around our environment, and we include things like email scanners, corporate firewalls, web gateways on the perimeter, looking at the outside world, looking at what's coming in from the outside world and saying, is that good or is it bad? If it's bad, we block it. As I said, we're preventing bad stuff coming in. And then the next step is then we take a look at our user community. So all of our internal users or even external users or the IoT devices, anything on the environment, we need to then try and protect. And one of the other ways that we do this is by adding this first line of defense, and again, preventing our users from doing bad stuff, whether it be a signature base as something that the user's done, they clicked on something or something like that. These tools are there to prevent that stuff from happening and prevent the bad stuff from kicking off afterwards. But a couple of things to mention here is this is not where any of our critical IT infrastructure is stored. It's here. It's in our data space. It's in our file shares. It's in our Active Directory. It's in our databases. And that's what we need to protect. We can't allow this multiple layer of protection to protect our crown jewel. Yeah. So what we see on a daily basis is that our users are accessing all of this infrastructure to go about their daily job. Not only internal users, as I said before, our external users, our customers may be accessing this for payment cards. So maybe we're selling stuff online or selling stuff and they want to pay us some money. If we lose this critical IT infrastructure, we cannot do any of that. So as I said, on a day-to-day basis, this is what we see. This is just normal good behavior. So what happens then if we introduce a ransomware attack to what we're seeing here? So in this case, what's going to happen? It's going to bypass our corporate firewall. Yeah, it's going to bypass our corporate firewall, and then it's going to hook onto one of the devices. It will then start to encrypt send its payload of encryption. It may do it locally, but it will more than likely want to then go into where it knows that it's going to get the biggest impact of the business, and that's our critical infrastructure. Once it starts encrypting there of around 40 to 50,000 files per minute, it will then move laterally around the environment, hooking onto other devices and finding other areas where data is stored, and then start to encrypt there as well. And this is targeted. So this is not just I'm taking a punt. They know your infrastructure. They've probably been in your infrastructure for a long time, doing reconnaissance, doing all those kind of things to gain access to be able to do this. And when we're ready, they deliver the payload and the encryption will start. And there's nothing left. Once that encryption starts, there's nothing left to stop this from happening. And you know what? It's actually two very simple pieces of information we need to be able to stop this ongoing encryption. We need to find out what files and where are being encrypted. Where do they reside? Are they on-prem? Are they in the cloud? Are they in a database? Where do they sit? I need that visibility before I can even try to stop it. The next thing I need to understand is the attacker. Which patient zero, which device, which user initiated this initial encryption? Yeah. If I can answer those two questions, I have a really good chance of stopping that ongoing encryption quickly, because I need to isolate that user. And there's a but to this. Today, nobody has that information. Once that encryption starts and starts to propagate around our environment at the rates that we've seen, we don't have the information to be able to stop that ongoing encryption. And if we can't answer those first 2 points, there's no way. It's impossible to do that. That third piece to stop the encryption. So what can we do that's different? So we'll go back to this simplified attack surface, and this time what we're going to do is we're going to put that Ricoh Ransomcare solution in a place where we are monitoring all of the traffic that goes on inside our critical IT infrastructure and our users. Yeah. So what we're seeing here is all the normal day-to-day behavior of users accessing data, accessing applications within inside this infrastructure. So anytime a user deletes, creates, modifies in any way a file or a folder or any information inside this infrastructure, we see that good behavior. Now, that's okay with good behavior, but what happens if it's not so good behavior and it's yet again another ransomware attack? So in this instance, we do the same thing. We follow that corporate firewall link in, bypassing that, and then going onto the device. But the split second we see a encryption starting to happen or any bad activity, we can then initiate an isolation. We have an isolation step path that we can use, and I'll talk through that in a moment on my next slide. But in fairness, what we see here is that one user is offline that will need to be recovered, but also the rest of the organization is able to continue to work without any disruption to business. So let's look at a workflow of a ransomware attack. Yeah, and what we do as part of those different stages. The first thing is we need to detect, and you'll see that done on a demo in a moment. Yeah, you'll see the detection and how we set that up and what we use to be able to detect the ransomware attack. And in this case, let's talk about we identify a ransomware attack by the physical encryption of the file. So the purpose of a ransomware attack, we will see that file encryption happening in real time. And we've got a whole bunch of different detection sensors to be able to pinpoint that we're detecting that ransomware attack. So the next thing we need to do is we need to respond. We need to immediately isolate the device and the user from that environment, which will then stop any further encryption. Yeah. we also need to alert. We need to alert you as IT and potentially the user. Yeah. And because we have different severity of what we class as an attack, we might want to look at how we respond in the different things. If I see 200 files being encrypted in a split second, I know that's a bad thing. If I see one file being changed to a known bad file extension, I maybe not want to isolate the device. I might just want to alert the user and IT. And we can do all of that based on building a response plan that we do for every single customer, and they're all tailor-made to your requirements. We also have integration with things like EDR, NAC, SIM, using RESTful API, and there's a really good benefit in doing some of that. But out of the box, we don't need to integrate with anything at all to be able to do the response piece. Recovery is also massively important because, as I said, one of the things we're looking for is file encryption. If we see file encryption happening, and it's a known bad file encryption, we will see a few files being encrypted during this process. Some of those files may even contain personal information, and I'll come on to that in a moment. But we will see some files being encrypted. But because we act so quickly, it's literally 20 files, 20, maybe 30 files maximum that we see. Bearing in mind that, ransomware attacks today are encrypting up to 50,000 files per minute. It's actually quite quick in the fact that we respond. But because we know what file and where they were, we can give admin that list of files, and we can recover those files from a backup. Because we've worked so quickly, the backup are never affected as well. We can also pinpoint the users and the devices that need to be recovered. So we will undoubtedly need to rebuild a laptop, and clean a laptop up. But again, it's better than having to do one device than every device in your environment, and knowing that when I add them back to the network, that it's safe to do so. We can also integrate here as well. So if you have a backup solution, something that, or a backup strategy, we can integrate with that to automate this process. Then finally, the last step is all around reporting. And as I said, if any of the files that we see during this process contain any personal information, one of the things a lot of organizations need to do is report that for NIST or GDPR. NIST 2 is going to be a part of it as well. So there's a lot of reporting that needs to be done externally. But also you may have a compliancy thing where you have to report any data breaches internally as well. And what we can do is these reports are tailor-made and can be automated as well. So there's a click of a button, it generates these reports for you. Finally, I want to talk a little bit about the architecture of the solution. And it's very important to mention that the solution is completely agentless. We do not install anything anywhere. There is no installation on any end device or any server, any domain controller, anywhere at all. So we do not install anything anywhere. Which also then gives us the ability not to add any performance overheads to the network or the devices themselves. We're actually invisible in the to the end users. So no installation on devices or any of the storage platforms or the servers that we're looking to monitor. All we need is a very small, lightweight VM server. We install the solution to the server, and then all we then do is we point the server at the files that we want to monitor. And this, again, we'll show you on the demo in a moment. Once we've pointed the server at the servers and areas that we want to monitor, and we call them monitor zones, we then listen out for things called file event notifications. These are happening right now in your environment. They are being they're being pushed around your environment today. So let me give you an example of this. If I have two users sat side by side that are doing that are in the same folder on a file share, and one deletes a file, the other user sees it automatically. That's done by file event notifications, and that's all we're listening out for. We don't need write act to be able to do any of our steps. We're just listening out for that file event notification. And then all we do is once we know what file has just been edited or manipulated, we then look at the file header. We don't look at the data, we look at the file header, and that file header gives us enough information to tell us whether or not this is a good or a bad action. And if it's bad, that's when we step in with our isolation steps. We work in the cloud as well. Work in the cloud as well. So if we have Office 365 or any business OneDrives or SharePoint or Google Drive, we are able to support and protect the data, not the users, protect the data inside these environments as well. So that's very simply how we work. And what I'm going to do now is I'm going to just check that the demo is ready. If not, it's not a problem. I've got a demo ready to go as well. So I'm just going to stop sharing for a second. If you just bear with me a second, and I will fire up the demo.
All right, so please let me know when you can see my screen.
We can.
Perfect. All right, so first, apologize guys for the technical issues that we've been facing, but now we can start the demo. So let me start the demo of Bullwall. So let me first explain the environment that I've got right now set up on my PC. I've got a domain controller and a Windows 10 PC connected to this domain controller. We've got Bullwall installed on the domain controller, and this is the dashboard that you see right now on the screen. Ideally, installing Bullwall should be in an independent server, so it can be in any virtual machine in your environment, whether it's local on-premise or it's on the cloud. So if you have a data center in Azure or AWS, we support that, and we're able to install Ransomcare in your environment. Ransomcare installation is relatively very simple. The installation of Ransomcare takes just a few hours. Just after a few hours of installation, this is what you'll see on your screen. After the installation is done, we run Ransomcare into one phase, which we call it the learning phase, before we go live. And what we do in the learning phase is, which usually takes anywhere between 2 to 4 weeks, is that Ransomcare would be sitting in your environment, learning all your users' habit, understand the different file types that you use, and store them in its own database to add it in the whitelist, which I'm going to explain in a bit right now. Once the learning phase is done, then we turn on the Ransomcare, and then you're protected from any encryption activity that happens in your environment. Before going to show you how really Ransomcare works, I want to show you a few screens and how we can set up the configuration of Ransomcare once the installation is done. So the first screen that we configure is usually we configure the detection screen or the monitoring zone. And this is the screen where we configure all where your data is stored. So here we show, we point to all your shared folders, and these shared folders can be anywhere in your network, whether it's a DFS or SharePoint or Google Drive or Office 365. We can protect your data and we can monitor the encryption. The only permission that we need is a read-only access to these files, so we're able to see all the changes that happens to these files. So we do not write anything at all on this folder. We just capture the notification messages that's already happening in your network when any file is created or changed. So we do not add any additional burden to your network, and we do not use any additional resources on your network. So we do not slow anything in your environment. The second screen is we have the detections page, and this page is split to two parts: the whitelist and the known bad. So let's talk a little bit first about the known bad. The known bad is the library of all the known ransomware applications that we know globally. This list is updated on an hourly basis. So we've got a team that's sitting in the back end. They're capturing all the information about any ransomware application, and we add it into to this list. One important point is that even if that ransomware application is not added or is not been known and it's not added to the known bad, so let's say, God forbid, you're attacked at number 0, then we still be able to capture it. We're still going to be able to protect your data from the encryption. So maybe the first question that comes in your mind, then why do we have the known bad list in here? It's just the reason, the only reason we have it here is just for a reference point. So this helps us to able, once we capture any ransomware application running in your environment, we'll able to tell you the name and give you the verification, the information about it much faster because we have got the information. But even if that ransomware is not here in the list, you're still protected because we only look into the encryption activity that happening in your environment, which is a suspicious encryption activity. On the left side, we've got the whitelist, and this is where we add, during the learning phase, we add all the different file types and their headers, so we know the file types that you're using, we know the headers of it. So anytime this changes into something suspicious, it will raise the alert bar, which I'll show you in a bit. Also, in the same list, we can add any encryption activity that you do, which is a legitimate, something that comes from your IT. We can add it, so whenever this encryption happen, it does not raise the bar and does not raise the alert level in your in the dashboard. Then we've got the detection sensor, and here we have 20 different kind of sensors, and these sensors' job is to detect those activities that happens in your environment, which are related to a ransomware application. Each of these sensors have if you want to know what kind of activity it can capture, if you just highlight your mouse over it, you'll get a description of what it does. We can change the pointing system because Ransomcare works on a pointing system. So here we can increase or decrease the number depending on your requirement, how much you want to be strict or lenient to in reacting to these activities. So why we have pointing system? Because we have also different alert levels. So we have alert levels and we also can customize that depending on how much you want to be alerted, or the different teams in your team that they want to be alerted. So we got all these pointing system, which all related to this to the activity and the alerting system, and whenever these alert level reached up, we notify you by an email. And here where we configure all the different email addresses, whether it's medium and high critical, so you can rest assured that you'll be well informed, even if your eye is not there on the dashboard, even if you're at night and sleeping, you would know, you'll be notified immediately by email if there's anything happens in your environment. So now I'll go back to the dashboard, and here I'm going to simulate a normal activity that is happening, creating files, different activity happening in your network. So right now, this application is creating different files for me, and this is how usually it would look like in your environment whenever there's a file that's been created, deleted, or modified. Now what I'll do is I'll go to my Windows 10 PC, and here I've got an application, application where we're going to create some generic files. So right now I'm going to be generating those files into this folder. So as you can see here right now, I've got this folder which has some files getting generated in it, and I'm just waiting for the activity is done. Once the files are created, then we're going to pick one of the ransomware applications that we have in our library. And this is the library of all the ransomware applications that we've got. These are all real ransomware, but our team has removed the worm capability so that it does not harm the environment and start spreading everywhere when we do our demos. For this example, I'm going to be using BabukLocker. And one important thing, these ransomware applications are very efficient. They can encrypt anywhere between 25 to 50,000 documents or files per minute. So they're very efficient. So what I'll do is right now I'm going to click on the button of attack. So what it will do, it will start encrypting the files for me. So as you could see here, the files are getting encrypted. So if I go back quickly to my Windows server, I can identify, Ransomcare was able immediately to identify that there's encryption happen. I can see the name of the user, the name of the user is Bullwall. I can see also where the files are located. So if I go back quickly to my Windows 10 PC, now any minute right now, and it sent the command. So as you could see, that the encryption has stopped. So the Windows 10 PC was shut down after sending a PowerShell command, which was sent in right now. It will take a few seconds in this environment because I'm running on a virtual machines and multiple virtuals on a laptop. So usually it's immediate. So, and this is how we switch off the Windows 10 PC by running the script command. Just wait. And what we do as well, after switching off the PC, we disable the user as well. So if I go back to, and I was logged in by the name of, by a user by his name is Bullwall. If I just right click, sorry, my server is a bit slow, that as you could see here. If I click just on the refresh button. Yeah, okay. Okay, so now we have identified the issue and we have stopped the attack. So we want to recover the data. So how can we recover the data is by just going to the button for recover. So as you could see here, there was an attack that happened today, and there's 424 files got affected. So if I click on it to show all the data, all the files that got affected during this attack. So if I just reset, just search by the name Bullwall, which we know the name of the user that got affected, that was, we have the application of ransomware running from his environment. We click on it and then we generate a CSV file. So with one click of a button, I was able to get the list of all the files that was affected during the attack. So you can share this file with your backup team to be able to recover the data from your backups. We also can support you by providing you a breach report. So it can generate for you a PDF file. This logo can be changed to your company logo, and it comes as an open form. So if you want to modify that and you put your name before presenting it to the management, for example. Also in this report, it will give you all the information about the breach. It will show you the name of the user, what his IP address, and the list of files that got encrypted during the attack. So with one just click of a button, we can able to generate a document with all the files that got encrypted in the attack. So this brings us to the end of the presentation, the demonstration. So if you have any question, please feel free to ask.
Thanks very much, Madge. There's no questions in the chat at the moment, but if anyone does have a question, you want to either raise your hand or put it in the chat, and we can answer straight away. If not, is it going back to you, Toby? We can also put the, we're going to put the feedback form into the chat. We'd really appreciate it if you could fill out the feedback form. Let us know what you think, tell us about your company, and then we can always arrange either a second demo, a POC, or another meeting independently with your company at a later date.
But
So
yeah, I can't see any questions in the chat, so I'll just explain the assessment and POC that we run just briefly. If there are any other questions, then please pop them in the chat. So what we do is we can offer free of charge a ransomware assessment test, and we kind of join the two together. We'll have a proof of concept and an assessment, and this includes a full installation actually of the RC console. We don't do any of the discovery, we just install it and we point it at test share. We send out a very short prerequisite that we need from each individual customer, and it should take about 30 minutes to set up the environment for us. Follow the prerequisites, and then we're ready to go. We'll do one call for about 40 minutes where we install and configure the environment ready for us to do the assessment. And then once that's done, we'll schedule a second call for another, again, about 30, 40 minutes, and we do the assessment and the proof of concept. And how that works is we do 3 different scenarios. We do 1, showing you what a ransomware attack would look like. We do 2, showing you how Bulwark and the solution will contain those outbreaks. And then thirdly, what we do then is we will stress test your environment against ransomware attacks. And we tend to do 3 or 4 different variants, like the ones you saw on Majid's demo with the different variants that we have in our library. We will throw some of those in and we will test out your defenses. And the output is mind-blowing, because we've tested against most ADs, antiviruses, most security tool sets, and unfortunately we're not as protected as we need to be. We tend to use WannaCry. WannaCry gets picked up about 95% of the time, but that's the only one that really gets picked up. All of those ones you saw today in that library of real ransomware, they walk through the defenses, they start their encryption process, and there's nothing in our environment and in our tool of security tools that will stop these ransomware attacks from propagating around the environment. Once we've done that, we'll follow up some reporting and give you guys the ability then to have a look and feel around the solution as well. And that's all free of charge. And like I say, it takes no more than 2 hours end to end. So that is something that we can offer everybody on the call. There are some caveats behind that, but we can discuss those offline. But yeah, more than happy to answer any more questions if there are any questions that have come up in the chat. And if not, I'll hand straight back to Graphic, who will close the call down. So that's me. Thank you very much indeed.
Yeah, thank you very much, Toby, for the presentation, and thanks so much, and Vicky. Yeah, the feedback form is already shared here. Whoever is participating, they can fill the form, and I will share the link of the same form by email to you, so you can anytime fill and send to us. Thank you for participating. Thank you very much.
Thank you, Mahesh. Bye-bye.
Thank you, everybody.
Thanks, everybody. Bye-bye. Bye-bye. Bye-bye.